This is the second part of the following problem. Suppose x and y are positive numbers such that x plus y equals 2. Find the minimum value of the expression, 1 divided by x plus 1 divided by the product of x and y. We are going to use the Cauchy inequality to solve the problem. Let's work through method 2 to find the minimum value of the given expression using Cauchy inequality. We will let the expression we need to minimize be represented as j. Now, using the fact that x plus y equals 2, we substitute y as 2 minus x. This gives us j equals 1 divided by x plus 1 divided by x times 2 minus x. We can simplify this further. We get j equals 1 divided by 2 times the sum of 3 divided by x plus 1 divided by 2 minus x. Now, by applying Cauchy inequality, we proceed as follows. By Cauchy inequality, the product of x plus 2 minus x and 3 divided by x plus 1 divided by 2 minus x is greater than or equal to the square of the square root of 3 plus 1. Simplifying this, we get 2 times 2 times j is greater than or equal to the square of the square root of 3 plus 1. This gives us j is greater than or equal to the square of the square root of 3 plus 1 divided by 4. Simplifying this results in j is greater than or equal to 2 plus the square root of 3 divided by 2. The equality holds when 3 divided by x squared equals 1 divided by 2 minus x squared. Solving this, we get x equals 3 minus the square root of 3, and y equals the square root of 3 minus 1. Thus, the minimum value of j is 2 plus the square root of 3 divided by 2, which is approximately 1.93. In method 2, we used the Cauchy inequality to arrive at the same result. While method 1 used calculus to determine the minimum value through derivatives, method 2 relied on inequality properties to establish a lower bound for the expression and showed that the minimum value occurs at the same point.